Here we go with the solutions to your review problems for 6.1 through 6.3. This is going to be part 1. Part 1 is going to be a little longer than part 2. I am going to go through a little fast, so make sure you've got that finger on the pause button, folks. Okay, our first problem is number 3, and I am doing this as an identity. And so I have chosen to work with the left-hand side, but I want to remind you of something. We're talking here about expanding a binomial that turns into a trinomial. When you expand a binomial, the first term will be the square of the first term, which is a squared. Your last term will be the square of the last term, which is b squared, and your middle term is multiply a and b together and double them, so it's plus 2ab. So don't lose sight of that. Okay, so we're going to do the same thing with tangent theta here. So we're going to have tangent squared theta plus 2 tangent theta cotangent theta plus cotangent squared theta. Notice that in the middle here we have tangent times cotangent. Any trig function times its reciprocal function is equal to 1. So this becomes tangent squared theta plus 2, because we have 2 times 1, plus cotangent squared theta, which will be, I'm going to divide this up into tangent squared theta plus 1 plus cotangent squared theta. How can I do that? Because I take the 2 and divvy it up there. Okay? So through your Pythagorean identities, you know that tangent squared theta plus 1 is secant squared theta, and 1 plus cotangent squared theta is cosecant squared theta. So there's your answer. On to the next one. Number 4. This is what the problem is. Okay? I am going to work with the left-hand side. And if I find my common denominator, it will be sine squared theta minus cosine squared theta when I multiply those two denominators together. So I've got to put sine theta minus cosine theta on the left, and sine theta plus cosine theta on the right. I'm sorry, sine theta minus and then sine theta plus. And I notice that my cosines zero themselves out, so I have 2 sine theta over sine squared theta cosine squared theta. Now if you look up at what we're trying to get this to be equal to, it's not near it yet. It kind of looks like it, but not quite. But here's what you have to think about. If I would multiply this times sine squared theta plus cosine squared theta, I would get my sine to the 4th theta minus cosine to the 4th theta. And how can I do that? Well, the way we can do that is when we multiply sine squared theta plus cosine squared theta, remember that's equal to 1. And I can multiply anything times 1. So if I multiply my denominator by 1, really it's sine squared theta plus cosine squared theta. So this gives me 2 sine theta over sine to the 4th theta minus cosine to the 4th theta. And I have what I'm looking for. Yay! Okay, the next one. I am going to work with the right-hand side, and I'm going to change everything to, well, first of all, I'm going to expand this. Cosecant squared theta minus 2 cosecant, not theta t, sorry, minus 2 cosecant t, cotangent t plus cotangent t squared. Once again, that's just binomial expansion. And then I'm going to change everything to sine and cosine. So I'll have 1 over sine squared theta minus 2 cosecant goes down to the bottom with sine, and cotangent becomes cosine over sine, plus cosine squared t over sine squared t. So my denominator is going to be sine squared t, and I can just gather my numerator. 1 minus 2 cosine t plus cosine squared t. And now I have to recognize once again that this is a perfect square. This is 1 minus cosine t times 1 minus cosine t over 1 minus cosine squared t, because I'm changing that with my Pythagorean identity. So this is 1 minus cosine t, 1 minus cosine t over 1 plus cosine t, 1 minus cosine t. Look what cancels out, and lo and behold, we have what we're looking for. Okay, we have the next one, number 6. I'm changing these to, changing everything to sine and cosine, and I have tangent t is sine t over cosine t times secant, which is 1 over cosine t. So I have a common denominator of cosine squared. So I'll have sine squared t plus cosine squared t, because I have to change the 1 to cosine squared t over cosine squared t plus sine t over cosine squared t. Okay, so I'm going to change my cosine squared t to 1 minus sine squared t right here. Okay, and so I have sine squared t plus 1 minus sine squared t plus sine t over cosine squared t. Ugh. Anyhow, my sine squared t's zero themselves out, and I have 1 plus sine t over cosine squared t, which is what I'm looking for. 7, 8, 9, 10, 11, 12. These are the answers to those plug them in problems. None of them are that difficult, so I'm going to kind of leave it up to you to make sure that you get the right answers. If you need help on it, let me know. Okay, number 15 is this one. And what I have chosen to do is I am going to make my changes to my double angle formula. Sine 2t, cosine 2 theta. Sine 2 theta, cosine 2 theta. So sine 2 theta is 2 sine theta cosine theta, and then of course I have my minus sine theta. And the bottom I'm going to use cosine squared theta minus sine squared theta plus cosine theta. Okay, so now this turns into, when I factor out my sine theta, it's sine theta times 2 cosine theta minus 1. And in the bottom, I'm going to change my sine squared theta to 1 minus cosine squared theta. Be careful of the negative sign that's in front of it, that you don't lose sight of that. Okay, so this is going to be sine theta times 2 cosine theta minus 1. Once again, just copying that down. And the bottom will now become 2 cosine squared theta minus 1 plus cosine theta. So once again, I have my same numerator, but now I'm going to change. I'm going to recognize that I can factor my denominator to 2 cosine theta minus 1 times cosine theta plus 1. If you don't believe it, change the cosine to x. 2x squared plus x minus 1 factors into this. I'm assuming you can remember that from Algebra 1 and Algebra 2. Okay, and these two things cancel out. So I have sine theta over cosine theta plus 1. Now I've kind of maybe reached a little bit of an impasse, so I'm going to go start working on the right-hand side. And about the only thing that I can do here to make any major change is to multiply by the conjugate of the numerator, which is 1 plus cosine theta. So this is going to give me 1 minus cosine squared theta over sine theta times 1 plus cosine theta. And I'm going to change my 1 minus cosine squared theta to sine squared theta by my Pythagorean identity over sine theta 1 plus cosine theta. The sines cancel, leaving a sine in the top and a 1 plus cosine theta in the bottom, and that's what we're looking for to match that. Okay, cosine of 4t. I'm going to work with the left-hand side, and I'm going to change this first to cosine of 2t plus 2t. And now when I use my double angle formula, I have cosine 2t minus sine 2t sine 2t. So this becomes cosine squared 2t minus sine squared 2t. I'm going to change the cosine squared 2t to 1 minus sine squared 2t, and then of course I have my minus sine squared 2t for the other other term. And now I put this together, it's 1 minus 2 sine squared 2t. And I'm going to break this up. Sine squared 2t is sine 2t sine 2t. And then I am going to apply one of my double angle formulas. Sine 2t is 2 sine x, sorry, I just changed to x. Ignore that little boo-boo. Sine 2x cosine x times 2x cosine x equals, now I multiply my 2 times 2 times 2, I get 8 sine squared x cosine squared x. And that's what I'm looking for. That was really a tough one. Okay, go on to your next video or take a rest and go get yourself something cold to drink. I'll see you later.